my understanding is that in the early 2000s, you see this, and you realize that actually doing that is a little bit difficult because what that researcher had to do is he had to sort of trick the GPUs into thinking that his problem was a graphics problem. Specifically, it's a platform called CUDA, which lets programmers tell the GPU what to do using programming languages that they already know, like C. And that's a big deal because it gives way more people easier access to all of this computing power.
And probably the first external ideas of using our GPUs for parallel processing emerged out of some interesting work in medical imaging. A couple of researchers at Mass General were using it to do CT reconstruction. They were using our graphics processors for that reason, and it inspired us. Meanwhile, the problem that we're trying to solve inside our company has to do with the fact that when you're trying to create these virtual worlds for video games, you would like it to be beautiful, but also dynamic. So there's particle physics you want to do, fluid dynamics you want to do, and that is much harder to do if your pipeline is only able to do computer graphics. And so we have a natural reason to want to do it in the market that we were serving. Fundamentally, the reason why I was certain that CUDA was going to be successful and we put the whole company behind it was because fundamentally, our GPU was going to be the highest volume parallel processors built in the world because the market of video games was so large.
It has seemed to me like creating CUDA was this incredibly optimistic, huge if true thing to do, where you were saying, if we create a way for many more people to use much more computing power, they might create incredible things.